Well, hello. My name's Adrian Gilbert and I'd like to welcome you once more to the Invisible College. Today's lecture is first in a series which I think you're going to find rather exciting on a subject that's close to my heart, which is alchemy. Now, of course, you may be wondering why on earth would someone in the 21st century be remotely interested in a strange pseudoscience from the Middle Ages where people thought they could manufacture gold out of lead using chemical methods that we know today as being impossible. But there's many reasons for this. There's many reasons why we should be interested in what these people were doing and what they were saying. But before we go into the actual subject of alchemy itself, I'd just like to say a few words about what it is that motivates me to want to investigate subjects like this. And it really comes down to a simple idea. And to illustrate this, I'd like to first of all talk about art. Now, I don't know if you maybe been to Spain. I've been there many times. And one time I was staying in the Costa Brava, and my wife and we went to a small town called Figueras, which is where Salvador Dali Museum is. And of course, we wanted to see this great tourist attraction of the area. And one of the things that really struck me while I was there, I mean, there's all sorts of bizarre things, you know what Salvador Dali was like. But one of the things that really struck me was there was a particular room. And if you went into this room, you'd see there's a sofa, there's a couple of pictures on the wall, and there's some curtains hanging. There's a particular type of wooden flooring, I think it was wooden. And you look at this and you think, well, yeah, it's kind of like a typical lounge, a salon, whatever they would call it. I don't know what the Spanish is. And you think, well, why has this been laid out like this? What is this all about? It's totally irrelevant, pointless even. But then when you went round to the other side of the wall, and there was a viewing point that you had to look through. And if you look through there in a particular way, it would click and you would see that everything laid out in that room made up the illusion of the face of Marilyn Monroe, one of the most famous images of the 20th century, perhaps the most famous after Princess Diana. So Salvador Dali was trying to say something here. He was saying, look, what you see is an illusion. What you're seeing, it's just how your brain interprets it. You know, it's still just a sofa. It's still just a couple of pictures on the wall and where the curtains hang and so on. But your brain looks at these images and it puts them together. I know what that is. That's Marilyn Monroe. And it's a little bit like that when you start looking into the past and you start looking at ancient wisdom. What do we mean by wisdom? And from the point of view of modern physics, modern science, these people were not wise at all. They were very stupid, in fact. But were they? You see, this is the other problem that we have. And I'll use another analogy. When we look out in the night sky, I don't know if you do this, I do this quite a lot, and you look up and you see the stars and you recognize certain patterns of stars and you say, yes, that's the constellation of Leo. Very recognizable. Or that's Orion, or that's the Big Dipper, which in England we would call the Plough. And so, I know those. Those are particular stars in those particular parts of the sky. But imagine if you were living on a planet. Let's say you were on a planet going round a star called Regulus, the Lionheart star in Leo, and you looked at your night sky. You wouldn't see what we see. You certainly wouldn't see the constellation of Leo laid out. You probably wouldn't see most of the others. They wouldn't look the same at all. You'd have to have your own sky map to define your own constellations that were appropriate to your space and your place and your time. And it's kind of like that with us, that I think it's been said before that the past is a different place. And it is, because the space that they are occupying is not just a physical space, it's also a mental space. So when we're looking at the past, we're looking with our own preconceptions. When we look at chemistry, say, alchemy, we're looking from the point of view of knowing all about atomic weights and atomic numbers and the periodic table of the elements. Yeah, we know about valency, we know about alkaline metal alkalis, and we know about metals. We know about you can't put sodium in water, it's going to burn. We know all these things. We're taught it in school. And so we look at alchemy and say, oh, these people were just ignorant. They didn't know that you can't sort of boil up things for a long time in a flask and expect them to turn into something entirely different. It's just not going to happen. But what we don't know is their mental constructs that led them to think that. What we don't appreciate is their space and their time. And you see, the reason I'm interested in that is because I suspect, and in fact I know, that in our time we've actually forgotten an awful lot. Yes, we've made huge advances and discoveries. Yeah, we can send people to the moon on a rocket. Been done. We can send probes out to the farthest parts of our solar system. Been done. We can investigate microscopic life. We can look at, we can look at the smallest of cells. We can penetrate further. We can get down to the molecular level, even the atomic level, and with hadron colliders, we can even start looking for bosons or whatever they are. But for all our advances and achievements in these areas, one suspects that there are whole areas of knowledge and experience and wisdom that have been lost and forgotten. And we feel this as a great void inside ourselves. We suspect that their understanding about, say, what happens after death was quite different from our own. They seem to have a kind of certainty that most of us today don't have. We look around ourselves and we see, there's Joe Bloggs, he's walking down the street there. Joe Bloggs has a heart attack and dies, and we see his dead body, and we say, well, that's the end of Joe Bloggs. What could possibly survive that? What could possibly, what knowledge could Joe Bloggs' soul, if he even has one, carry with him to some other place? Where would that other place be? Yeah, it's on the pole star. Is it in Orion? Where is it? So we have this inbuilt skepticism built out of the fact that we have a particular mind view, basically based on science, chemistry, physics, our understanding of the material world, that says you can't go faster than the speed of light. You can't make gold out of lead. You can't expect anything to survive death. And because we have this certain mindset, we don't fully understand what the people in the past were up to, where they were going with what they were doing, what was really important to them. It's written in a different language. It's as different to us as, the Phaistos disc, and we can't decode it. We just don't know what's going on. But there are certain things, certain subjects, that can give us some of that knowledge and begin to illuminate us with a deeper understanding, a deeper wisdom. And one of those subjects is alchemy. And that's kind of why I want to go into it in some depth. Now, the word alchemy itself comes from alchem, which is an Arabic word, I believe, and they apply it to Egypt. I think it means the Black Land. And the Black Land was not because the people living there were black. It was because the delta area of Egypt had kind of beautiful black soil that was extremely fertile, that they could grow 3 crops a year on. And as opposed to the desert, which they call the Red Land, outside of the Nile Valley and the delta. So Egypt, the inhabitable part of Egypt, was known as the Black Land, or Kemu. And Al-Kemu became the science of the people who lived in the Black Land, alchemy. And it covered a whole range of different subjects and areas, not just making gold out of different minerals, but also taking plants and extracting their vital essences, which is very useful if you're into herbalism. I mean, we still actually do this today. I don't know if you realise this, but most of the pharmaceuticals that you'll see in the chemist shop actually derive from plants. And this would all be part of the Egyptian knowledge. How do you make a powder out of lapis lazuli? You grind it up and then you put the powder with certain wax or oils or whatever to make your makeup, which you could then paint onto your eyebrows. And this is kind of, to the other peoples in their time, seemed extremely strange. And the Egyptians became famous because they were able to do these things which to other people looked like magic. And another thing that the Egyptians were very famous for, of course, was mummies. And the Egyptian process of mummification, we've only just recently begun to understand what they were doing. That they learnt how you could use salt, large quantities of salt, to pull the water out of flesh, to dry it out. So the whole process of mummification is really about drying out flesh so that it will be preserved. It's like making beef jerky out of your granddad, It's as basic as that, really. But the whole reason they were doing this, of course, is that they believed in life after death. They believed it was important to preserve the body because the soul could come back to that body and resurrect it. Actually, Christians have similar ideas of the idea of the resurrection of the dead. At the end of time, the end of the world, when Jesus comes back, all the dead bodies come out of the ground. You'll see this in in Christian art all over the place. The Egyptians had similar kinds of belief, but they also believed in certain kinds of subtle bodies. We'll be talking about that later. And of course, that's come down to us today in the form of sort of Boris Karloff and the Mummy's Return and mummies staggering around like zombies attacking people, and we think, spooky old Egypt. But that wasn't really how it was at the time. The Egyptians believed things that we've kind of lost sight of. And that's another reason why I'm so interested in ancient Egypt. I've written quite a bit about it, written with Robert Bauval about it as well. So this is kind of, alchemy is one of the windows that we can begin to look into all of these subjects. But it wasn't only the Egyptians who were interested in metals, of course. Here in England, there have been some remarkable archaeological discoveries made. There's a particular cup, gold cup, I think it's in the British Museum at the moment, that was discovered in Bodmin Moor. And that was in the 1837. And amazing piece of workmanship of this cup, hammered out from a single piece of gold. This is one of the things about gold, is it's very malleable. That means you can hammer it and make very thin sheets. In fact, you can hammer it so thin, you can make it so wispy that you can stick this on and gold plate things with it. And people, of course, have done right through the ages. Now, in 332 BC, Alexander the Great, the Greek leader from Macedonia, led his army into Egypt and freed it from Persian rule. Persians regarded Alexander as being an incarnation of the devil, but the Egyptians considered him a liberator, and in fact, when he went to the oracle at Siwa, he was confirmed that he was the son of a god Ammon, the high god who the Greeks equated with Zeus or Jupiter. So Alexander was sort of regarded as a liberator in Egypt, and his successors, not directly but through his general Ptolemy, became the new pharaohs in Egypt, culminating, of course, with the famous Cleopatra. Now, the Greeks were fascinated by Egypt and all of the ancient wisdom that they found there, and not least by alchemy. And they equated Thoth with another of their gods called Hermes. But to distinguish him from the kind of youthful Hermes, the one with the winged hat and the messenger of the gods, they called this one Hermes Trismegistus, Hermes the thrice great. And he was visualized as being an old man, a teacher, very wise, running a school, going way back to the earliest days of ancient Egypt. Now, just as with Thoth was credited with having written many, many books. Now, we know that some of these books were what we now call the Book of the Dead. The various recensions of the Book of the Dead. There's the scrolls which have been found in some tombs and coffins. There's actual text written inside coffins and on the outsides of them, called the coffin texts, for obvious reasons. And then there's also inscribed inside some of the pyramids, there are texts known as the pyramid texts. These are all regarded as being either extracts or prayers or hymns, spells, based on the teachings that would have been contained in the Book of Thoth. Well, we don't know where those books are. We hope that they might still be in existence, that one day someone's going to open up a chamber in the pyramids and we're going to find scrolls with, the real McCoy, a whole library of texts, either, as I say, written on scrolls or maybe on clay tablets like they have in Mesopotamia. Who knows? But the Greeks, they regarded Thoth as being Hermes, and because they couldn't find his books, they decided to write some of their own. And this is a common technique, that if you were a member of a school, an esoteric school, and you were in the tradition, let's say, of the teachings, it was quite okay for a senior member, the teacher of the day, to write his teachings and attribute them to the master, because after all, the master is the one that's kind of inspiring him to his great work. So the Greeks produced a whole series of writings attributed to Hermes Trismegistus, which we now call the Hermetica. And among these Hermetica, there were various texts, such as one called the Emerald Table of Hermes, which is probably the most famous alchemical work to come down to us from the ancient world. And we'll be talking about that a bit more in later lectures. But they were sort of intrigued by Thoth and by Hermes and his lost books. And they began to also become very interested in alchemy, if they hadn't been already. They certainly became intrigued by it and attributed this to Thoth, because, of course, he was supposed to have taught the Egyptians their sciences. And actually there's another connection here that's important too, and that is with the Hebrew tradition. The Hebrew tradition looks back to a great teacher called Enoch. And you may have heard of the Book of Enoch. And Enoch meets the angels, and he talks to God, and eventually he's taken off earth, body, soul, spirit, altogether. The first one to do that. Well, the Hebrews equated Enoch with Thoth as well, and with Hermes. So we have this idea of the books of Enoch and the teachings of Enoch being pre-diluvian, before the flood. Enoch's the great-grandfather of Noah. So before the flood, this great wisdom was in existence, and some of it's been preserved, we hope, in writings in the book of Enoch. And then some of the Hermetica, they talk about how Hermes wrote on tablets and on pyramids and on stelae, and that one day these things will be found and his great teachings will be rediscovered. Meanwhile, they started doing their own writings and wrote a whole series of chemical texts. Well, a lot of Greek writings were produced in Alexandria in the 2nd century BC onwards. And if you looked at the sort of apparatus that people were using for producing chemistry, it's not so very different from what we would recognize today. They had, these kind of flasks where you sort of heat something in one flask and you condense it into another. And we see this today, and that would be understandable to people from those times as well. They had this kind of technique going on, and the Egyptians were very, very good at this, and the Greeks learnt from them, and gradually they were assimilating this knowledge and bringing it into the kind of European world, so that by the time when the Romans came along, the Greeks themselves were regarded as the great physicians and teachers of the ancient world, and Romans would employ Greek teachers to teach their children all about, I suppose, what you would call civilized ideas, the liberal arts. What differentiates our understanding of chemistry today from the old alchemy of previous times is that we have a very systematized view of matter. We understand that everything exists, everything from a table, to a piece of plastic. Everything that exists is composed of atoms, and that these atoms themselves come as different varieties. So we have oxygen atoms in the air, we have carbon atoms, we have atoms of metals like iron and tin and zinc. We understand that the atoms themselves are more or less stable. You can't change them, not easily. To change an atom from one thing into another requires an atomic reactor or a star, if you've got one handy. But in those days, they didn't look at things that way. They didn't have the periodic table of the elements. They didn't know about valency. They didn't know that some atoms are metallic and others are non-metallic, and that you can combine them in very predictable ways. As far as they were concerned, there was matter, and matter was all the same. All that was different about things, what made one piece of matter different from another piece of matter, was its appearance, its characteristics. So you could have a lump of iron, for example, and matter as such was exactly the same as the matter in a piece of lead. All that was different was that the iron had iron characteristics and the lead had lead characteristics. And so if you were an alchemist, what you were trying to do was change the characteristics, the appearance of whatever it is that you were working on. That you take the lump of lead and you change its appearance so it looks like gold. And then it is gold. Now that sounds daft to us today, doesn't it? Because we know very well that all that glitters is not gold. That you need to have actually got the atoms, of gold, not lead. And it doesn't matter, how you meddle around with the appearance, it's still not going to be gold unless it is gold. But that wasn't so apparent to the ancient peoples. And actually, they didn't have our periodic table. They didn't know about most of what we see on the periodic table of the elements. They only knew, really, of 7 metals. There was iron, obvious, copper, silver, gold, mercury, tin and lead. These 7 metals were what they would recognize and call metal. And you could mix them and you can make other things. Now, the interesting thing is that they did actually use certain other metals without realizing it, or certainly without defining them. For instance, they used aluminium in a salt called alum. Alum is a mixture of aluminium sulfate with ferrous sulfate. Now, the Hermetic doctrine, and this applies to alchemy like everything else, was the concept, the simple concept that everything that happens down here on earth mirrors that which happens in the heavens. In other words, as above, so below. This was actually a doctrine of cosmoses, the idea that the way that everything is worked, made by God, is mirrored in the greater cosmos and in the smaller cosmos, which can be the planet or it can actually be the human body. And this is a doctrine which goes way, way back into antiquity and is still actually underlies a lot of the teachings in the modern day Christian church, although people are not so aware of it anymore. Anyway, so the Hermeticists, when they were trying to think about how they could manufacture metals or extract metals, everything to do with these precious metals and transformations, they looked for their inspiration to the way that God had created creation, or at least the way they believed he had created creation. And so within their teachings, as in the Bible, God begins his creation by issuing light. First logos, let there be light, and there was light. So the first creation of God is the light, and then the separating the light from the dark. And then once that's been done, there's a big bang. Yes, it's exactly the same as we talk about today. The idea that this energy has been created and then it's released, creating a big bang of dust clouds, storms, huge amounts of matter in the universe floating around. But the Hermetic doctrine is that this then kind of coalesced and condensed. This actually, again, goes way back into ancient Egyptian teachings where they believed that God, and excuse me being a little rude here maybe, but God's first creation was like a gigantic ejaculation. And what he put out into the universe, his ejaculate, if you like, then begins to separate out the lighter, thinner fractions forming spheres of fire and air, and the heavier, denser parts forming spheres of matter and water, liquid. So there's this kind of separating after the Big Bang takes place that is recognized by the Hermeticists as being kind of the progress of creation. And through that progress, first of all, the stars are made. There's a creation of a star out of the fiery matter in the outer parts of the creation. The stars are formed. And then gradually within the inner process, you've got to remember that they were thinking in terms of the earth being at the center of the universe. This is how people used to think of things. We now know that that's not correct. But they believed that the earth was at the center of the universe. But very curiously, what we have found using our Hubble telescope and another means is that indeed stars are formed within dust clouds, within the galaxy. For instance, in Orion, there's a massive dust cloud called the Orion Nebula, and astronomers have now found stars actually in the process of being born within this nebula. So the Egyptians were actually correct, and the ancient Hermeticists were correct in thinking that stars are formed out of a coalescing of this sort of matter up in space, this thinner, more attenuated matter condensing to form stars. Well then, having sorted out the starry realm within Hermetic teachings, the sun is born. Again, they were thinking that birth must happen within the centre, so the sun is born in the centre, but then they have to explain why it's not still at the centre, so they believed it then migrated to its proper sphere, which is the third sphere within the Hermetic doctrines. Actually, that sphere, properly speaking, belongs to the Earth. The Earth is the third planet out from the sun. So what we've done is we've substituted our position for the sun's position, assuming that it goes round us rather than us round it. Easy accident to make, and actually in some respects not that untrue. I mean, where is the centre of the universe? It's not the sun, is it? May as well think of where we stand as being the centre of the universe, because it is for us. So it's not totally stupid what they were saying and thinking, but anyway, they then believe that following the birth of the sun, it moves to its rightful position, and then after that, the planets are born. The sun creates the solar logos, creates the planets to go in their rightful orbits around in their spheres. And meanwhile, the Earth itself condenses. And they didn't really understand that the Earth is just a planet. As far as they were concerned, it was kind of like the hard, rocky bit at the centre of the universe. But interestingly, with the creation of the planets, we now know that also is not a daft idea, that as well as seeing these suns being formed in certain nebula clouds, astronomers have found evidence seeing what are called protoplanetary disks forming around the stars. The idea is that a lot of the dust and gas and everything condenses to form a star, but there's still a sort of rim of material circulating around it. And gradually this condenses into knots and lumps, which gradually accumulate as boulders and rocks and water as ice, and lumps together to form planets, and you get a system of planets. And it wasn't that long ago that we assumed that all planets, that all stars were just stars, and that it's a real rarity to have planets. It's quite possible that this was the only star with planets, that people were thinking that. Now we know from minute observations using some of the most modern equipment that actually it seems like most stars have got planets, perhaps all of them. There's nothing unique in having a planetary system. The problem now is finding stars which have planets in what they call the Goldilocks zone, when it's not too far out from the star, or not too close. So it's just in the right area for water to be a liquid, and that seems to be the requirement for life. So that's kind of what they're looking for. That's a digression. What we have realised is that the metals and the elements are formed within stars. It takes enormous pressures and temperatures and coalescing forces to push nuclei together to make gold or silver or lead. The idea you can do it in a test tube, we now regard as being nonsense. Perhaps in the future some technique will be discovered and it will be found not to be a nonsense. But at the moment, the state of our knowledge, we believe that all the metals and everything is made in stars, and then when the stars die, as they do. Everything's born, grows, and then dies. The stars disperse their material into the universe, into the galaxy, into the fresh dust clouds, and then later those are coalesced. So within the stars, those metals are then condensed, and within planets they're condensed, so that our planet has brought into itself quantities of gold and silver and lead, tin and iron and all the rest of the metals, the elements that we know. And what we do is we extract those elements and we make them into usable things. Whether that's true, I don't know. I mean, it seems to be true as far as we know at the moment. But of course, in the ancient times, they didn't think that. They thought that metals are made inside the earth. That, particularly with volcanoes, it seemed to be that a lot of these minerals are found around volcanoes, which is not unreasonable, because they're throwing stuff out from the centre of the earth. You're going to get the heavy metals and so forth within these volcanic rocks. But they believe that they're actually being manufactured inside the earth and then spewed out. So what they wanted to do was to emulate these processes. They wanted to actually create their own, if you like, mini earth, mini volcano, in which they could take seeds of the metals and grow them and harvest them and turn them from one thing into another. And we'll be looking more into that in a later lecture. Now, the Egyptians, within their alchemy, they actually were not great theoreticians. That all came much later. The alchemical texts that we pore over, we're going to be looking at some of those later. The drawings and all of that, that all came much later. What the Egyptians were experts at was practicality. As far as they were concerned, alchemy, chemistry was a practical process. They didn't want a highfalutin philosophy about it. They wanted to be good at doing it. And a lot of the apparatus that we use today, things like retorts and flasks, would have been fairly familiar to them. They had these things. They knew that you need to heat something up and condense what's been evaporated. You find that you need something cooler to condense it in so that you can separate out the fine from the coarse. That was another Egyptian teaching. You must separate out the fine from the coarse. Fine, in this case, being your metal that you're trying to get hold of, and the coarse being the ore in which you find it initially. And they would have sort of had furnaces not too dissimilar from those we see in medieval drawings of alchemists at work. Actually, we know that there are iron smelters and smelters for all the other metals, like making bronze. If you wanted to make a bronze sword, for example, you needed to have a furnace that could get to a high enough temperature that you could melt your copper, you could melt your tin, you could mix them together, and then you could pour out into a mould and you would make your sword, which you could then sharpen and polish. This goes way back, and actually archaeologists have found the remains of these furnaces. And they were not too dissimilar from those which are used by medieval people as well. What they didn't have at the time was a means of measuring exactly the purity of gold. That required the great genius of Archimedes. Everyone's heard of Archimedes sitting in his bath and going, "Eureka!" Yeah, well, actually what the eureka moment was for him was he had realised that when you put something into a bath of water, it pushes the water out the same volume as the thing you put into it. In other words, you get into your bath, if it's full up, the water flows out over the side. And that was his eureka moment, because he realised that if you could weigh the amount of water that you displaced, and you could weigh the thing that you're putting into it, you could work out its specific gravity. And if you know the specific gravity of pure gold, you can then tell if something like a crown, for instance, is pure or not, because you can put it into a bath of water, a basin of water, and displace the water and measure how much has been displaced, so you can know exactly the weight of water, and you can weigh the crown, you can get its specific gravity, and you can see if it's made of pure gold or not. That was a later invention of the Greeks. But the Egyptians still, even so, were able to produce very, very pure gold. The famous mask of Tutankhamun, has pure gold within it, parts of it. But they also knew how to mix gold with other things. And we know this because a remarkable papyrus was discovered in Egypt. As usual, there were people busy grave robbing. And this time they opened a grave and they found inside one of the coffins, which turned out to probably have been the coffin of an alchemist, a load of papyri, including a couple which were actually manuals for alchemy. This is a remarkable discovery because at the time when this person was being buried was during the reign of Diocletian, the Roman emperor. And he ruled around the end of the 3rd and beginning of the 4th century. And he passed an edict banning alchemy and ordering that all such documents should be destroyed. I mean, his concern was that people were making these metals and debasing the currency. So it's a common problem, isn't it? I mean, our own currency is totally debased now, but in those days they were very concerned about the quality of copper currency, of silver currency, of gold currency, that it should be optimum. So he banned alchemy and he banned all these texts, and someone must have concealed these recipes inside the coffin of someone who had died, a dead alchemist, maybe the master of the person who was doing the concealing. And they were brand new papyri, so they were in very good condition when they were found. And these were bought by a Norwegian diplomat, and he gave one set to Leyden University, which is in the Netherlands, and another set to Sweden. And for a long time, people just didn't really think any more about these texts. They're written in Greek, not in Egyptian hieroglyphics, although they're written on papyri. And nobody really thought very much about these. In 1830, the director of Leyden University noticed that one of the papyri in the collection, for which he was responsible, dealt almost exclusively with alchemy. It seemed to be a sort of recipe book that would have served as a manual for someone already engaged in these practices. As such, it was priceless in the light it threw upon the development of chemistry itself. To distinguish it from the other papyri, which mostly dealt with religious or magical matters, this one's generally known as the Leyden X Codex, Leyden 10. So the Leyden 10 Codex gave us our first real insight into what these alchemists were actually all about, as opposed to what had been assumed that they were all about. And the recipes come in 3 different categories. First of all, there's recipes for making gold-like alloys, testing for the purity of gold, and plating with gold. Now, these would be practical processes that any Egyptian alchemist, goldsmith, whatever title they used in those days, would have had to have known about. The Egyptians certainly used different grades of gold for different purposes. Sometimes you needed absolute purity. Other times you needed a certain amount of strength, which meant you had to dilute your gold with other metals. They also used electrum a lot, which is a mixture of gold and silver. And they used to put that on the top of their obelisks. And then there were recipes for staining or colouring the surfaces of alloys and crystals. And actually you can see some of this work if you look at the jewellery discovered with Tutankhamun. A lot of it is what we would today call paste. Semi-precious stones, glass beads, But, these could be coloured, these could be stained to make them look like the real thing. And in fact, I'm sure the same processes or something similar are used today when making paste jewellery. And then there was the third set, which were about how to make letters of gold for writing. So again, practical use, presumably using gold leaf or some such equivalent. You could lay out your gold leaf and cut it out to make letters to stick on things. So these texts were very, very important and a remarkable discovery when they were found. Now, they had stoves, or athanors as they're called in alchemy, which were probably not much dissimilar from this, which is how they looked in the medieval time. You had a brick-built kiln which you could light a fire under and get up a high temperature. And then you had your sort of areas above it that you could put your material into to melt it down or to cook it. You were taking ores principally and heating them to a high temperature to break them down. Now, as you can see on this one here, the top could be taken off. It's like a kind of flue vent, and the gases that go up through the flue could condense in this colder region and form a layering of powder or crystals inside the top, and that could be taken off and these could be scraped out. And these were called this material taken from the top of the Athena, this evaporated material, is called asem, which is a fairly general term, but was absolutely vital for the production of the gold or gold substitute that they were busy making. And of course, asem could come in all sorts of different shapes and sizes. It depended on the skill of the alchemist who's working. It depended on his first material that he's cooking up in there. If you heat one mineral, it's going to produce one thing. If you heat something else, it's going to produce another. So the recipe books are very helpful in this respect. They tell you what you should be working with, and it tells you the qualities of your asem and what it can then be used for. So this gives us our first insight into how alchemy as such came to be this kind of mystical, magical process, because while they talk about the asem, they don't always describe exactly what it contains. And there would be a certain amount of knowledge which was passed on by mouth from the master to the apprentice that wasn't committed to writing, but the apprentice who had been through the course, who had been initiated into the subject, would know exactly what's being talked about, and the recipes would act as a sort of aide-memoire. Now, from the Leyden Papyrus gives us gives details for making a brass from asem. And I'm going to read you out one of the recipes here that tells us exactly what's to be done and how. It goes like this. An exact preparation of asem, preferable to that of asem properly so called. Take orichalcum, 1 drachma, for example. Place in a crucible until it melts. Throw upon it 4 drachmas of salt of Ammon of Cappadocian salt. Remelt. Add to it lamellose alum in an equal amount to the weight of an Egyptian bean. Remelt. Add to it 1 drachma of decomposed sandarach, not the golden sandarach, but that which whitens. Then transfer to another crucible previously coated with earth of Chios. After fusion, add a 4th part of asem and put into use. Now, people have worked on this and researched what these different minerals were, and to the best of our knowledge and ability, this is what they think they've come up with. Orichalcum, or or richalcum, as it was sometimes spelled, was an alloy consisting mainly of copper and zinc. In other words, what we term today as brass. The term decomposed sandarak in the above would seem to indicate that the native arsenic sulfides were sometimes roasted, and the resulting product, which would be essentially arsenious oxide, was then used in making alloys. And the use of metallic salts and their compounds rather than pure elements is quite common in alchemy. It certainly is. That, they didn't have zinc, they didn't have magnesium, not in their native free elemental forms, but they did have their oxides available, which seems to have been what was coated inside the lid of some of these things. They also had arsenic. You can imagine that if you're cooking up these heavy metal sort of copper sulfide or copper iron sulfides mixed together, they often do have arsenic in them and antimony, very poisonous materials. So you can imagine that the poor old alchemists, they didn't realize it, but they were actually handling quite dangerous substances, and I expect not a few of them ended up losing their teeth or going blind or dying even from the effects of these materials. It's a bit like Madame Curie handling radium without realizing the dangers of radiation. Anyway, so they would make their arsam in this way, but they were still stuck with the basic principle of what you're going to apply it to. We can imagine that this powder, which is scraped off from inside the chimney of the ethanol that they've been roasting their materials in, and it's actually probably zinc oxide or magnesium oxide. This would actually be the origins of this idea of the philosopher's stone, that you could have this powdered material, this philosopher's stone that you could project onto your other material and it would turn it into gold. And this actually was, the Egyptians knew what they were doing. They were taking these zinc or magnesium oxides and maybe some aluminium oxide and throwing it into their copper oxide, the black stuff, and heating the whole lot together, and eventually they come out with some kind of a brass material that looked a lot like gold. So it is a very, very practical process. But we can look a little bit more at the actual materials, because of course for the alchemists of the Middle Ages, looking at what had come down to them, and we'll be talking about that a lot in the next lecture, it was all important to know what your first material was meant to be. Because the gold was always what you wanted to end up with. It's the royal metal par excellence. You would also want to make silver if you could, because especially the ancient Egyptians, silver was actually quite a rare commodity. They had to import it. So if you can make something that looks like and behaves like silver, that would also be, something good to be able to do. Of course, for the practicing alchemist, the goal was to make something which was like gold to look at. Gold was the most desirable metal. And the best way to do that was to use copper as your basis and to add other metals to it to change its appearance. So that meant they had to look for, as their first material, actually some kind of mineral of copper. And the obvious place to look for that would be on Cyprus, the island of copper. Copper actually gets its name, Kypros, from Cyprus, Kypros, because they had massive mines there to supply copper to the ancient world, which was then used mostly for making bronze. And you had different kinds of ores available. The simplest ore you could find was the copper oxide, which is a crystalline form called cuprite. And all you've got to do with your cuprite is mix it with black charcoal, which is actually carbon, and heat it very strongly. Crush it up, heat it strongly with the carbon. And the carbon takes away the oxygen, and you end up with your your reddish coloured metal, copper. But that was a fairly rare material, fairly rare mineral, even in those days. More likely, you were going to have malachite, which is a hydrogenated carbonate of copper. And again, this isn't that plentiful, but you could get your malachite, heat that up strongly to drive off carbon dioxide, and that would leave you with a black oxide of copper, which you could then mix with carbon, probably in the form of charcoal, ground up charcoal, heat that strongly, and again carbon dioxide would be passed off, and you would end up with your red copper, your red material that you could then work with. If you're a bit more skilled at your chemistry, you could use chalconite, which is another material containing copper mixed with iron as well, but that takes a bit more processing. So they had various different minerals at their disposal, and the aim was that you would make a white powder, first of all, which would be your zinc oxide, basically, or your aluminium oxide, magnesium oxide mixtures, perhaps with some arsenic as well. And you make your red powder, which would be your copper oxide, reduced to copper. Mix the two together and cook it hard, and you'd end up with a kind of brass, which you could then use in place of gold. This would be your philosophic gold. The Romans made ceremonial armour out of brass, but they weren't the first people to discover this very versatile amalgam of different metals. The Egyptians were certainly involved in this long before then. So we can see from the Leyden Papyrus that actually Egyptian alchemy, there was nothing magical about it. It was nothing to do with mummies. It was nothing to do with spells. It was nothing to do with magic circles and pentagrams. It was all about chemistry. And it was all about producing useful metals that you could make things out of, whether it's bronze or brass or electrum or different grades of gold. This is what they were really about. But of course that whole understanding disappeared, so that by the time we got to the Middle Ages, a whole Baroque science, a whole Baroque understanding of what alchemy was all about had grown up, and it gave rise to its own ideas and processes, and we'll be looking at that in the next lecture. Thank you very much.